Well, good morning, scientists. So we're here again. Today is Thursday. So first of all, hopefully you had a happy Passover last night, and if you're celebrating Easter this coming weekend, have a happy Easter with you and your family. And unfortunately, we can't all get together and stuff like that with families, but hopefully you're able to connect kind of like I'm connecting to you right now. So, speaking of connecting, try to stay connected with your friends and stuff and your classmates during this time. Share some ideas how to stay organized, how to best work out being successful with distance learning, and also how to stay organized and keeping track of your assignments. I know today on the announcements I posted an attachment that Ms. Lopez shared with me that you could either print out, copy, or you take some notes on, do it online, where each day you kind of just list what your assignments are, what the due dates, and what your questions are. So use that, share some strategies if that works for you. If you got another way of making things work for you that you want to share with some of your classmates, let me know. I could share it on one of these videos or put it on my announcements. Speaking of other things going on today to share ideas, I'm going to have a question and answer session today. I'm going to have two question and answer sessions today from 12 to 12:30 for my advanced classes. That is periods 1, 2, 3, and 4. There'll be a link at the bottom of this announcement to click on, and you can join through Teams. And at that time, you don't have to join, but at that time, if you have any questions about astronomy, stars, or about Canvas, join and ask me some questions, and I'll do my best to help you out. And if you have questions just about anything else in general, about school or distance learning, let me know. From 12:30 to 1 o'clock, I'm going to have the same thing for periods 5 and 6. So if you're in periods 5 and 6, it's going to be from 12:30 to 1. There'll be another link. It'll be a link down below. You click on that and join. Again, you don't have to join, but if you have any questions and answers, or you want to check in and talk to me a little bit about a few things, that's the time. All right, so I'll try to do that once a week. To review a few things from this week about astronomy. First of all, the three things that determine a star's brightness is number one, its size. So how big a star is determines its brightness. Second thing that determines its brightness is its temperature. The hotter the star, that's right, the brighter they are. So, and the third thing would be the distance. A star that's closer to the Earth is going to look much brighter. Like, for example, the sun's coming out right over here, and it looks pretty bright because it's very close. So it's about 93 million miles away, or about 150 million kilometers. So that's the closest star to us. Are there any other stars in our solar system? No, there's not. The sun's the only one. If we had more than one star in our solar system, it would be a little too hot here. So only one star in our solar system. However, other solar systems do have 2 or sometimes 3 stars. Nuclear fusion. Nuclear fusion, let's say I'll take some stuff out of my breakfast here. So if you have 2 atoms, let's say that both have 1 proton each, like for example, we got 2 atoms of hydrogen. Inside of a star, it's so hot, there's so much pressure. If they get fused together, and now they become 1 atom that has 2 protons, so now it went from a hydrogen atom, now we have a helium atom. So that's nuclear fusion. When these two fuse together, unlike these raspberries here, when they actually fuse together, they actually give off a lot of energy. So I'm just gonna eat them and get the energy that way. So, life cycle of stars. You read about that yesterday, and also that was the brain pop that some of you are doing today, is the life cycle of stars. Some of you I already saw did that ahead of time, great. If you didn't, the brain pop, there's 2 assignments there. There's the quiz, and there's the make a map, where you're supposed to make like a little timeline, the life cycle of the stars. If you can't get the map to work, a few students had some trouble with that, that's okay. Just do the quiz, don't worry about the map. But the map is a good review. I'm gonna post a little diagram of the life cycle of the stars probably on Monday, and I'll have you kind of copy that down in your notes. So stars, they start out as a big cloud of gas and dust. Gravity pulls it together, it forms a protostar. Proto means prefix, that means before or first. So forms a protostar. Once that protostar gets going and nuclear fusion begins, becomes an actual star. Then that star, depending on its mass, it either becomes a main sequence star like our sun, goes through its life cycle, it ends as a dwarf star. If it's a more massive star, it's going to go through its life cycle much faster. It'll end up as a supergiant, or as a giant star, and then go supernova at the end of its life. Our sun won't do that, it's not big enough. Or if it's a really big star, even more massive, it goes through its life cycle even faster. The bigger the stars are, the faster they go through their life, and then it ends as a black hole. Again, our sun's not going to do that. So those are the different ways stars could end their lives. And that's about it. I'm trying to think, do I have anything else I wanted to cover today? Nope, I'll be grading the answers to the reading assignment that you turned in this week. I'll be looking at all those today and Monday, grading those. When I do grade it, look for the feedback. All right, so stay curious. I'll talk to you again either today at the question and answer session. Otherwise, keep an eye out for one of these videos on Monday.